So what we're going to do is we are going to try to basically reinvent the wheel here. So this is from the Miata that we were working on, and it had a bad idle control valve, so I set the idle higher, but now it's gotten to the point where the customer just cannot deal with it anymore. The biggest problem is that these valves are extremely expensive. Like in the used market, they're $200, which makes zero sense to me. Just because that, yes, you buy a used one now and it may work, but what's going to happen in a few years when it fails? So what we're going to do is we're just going to make an idle valve. So now that we have the idle valve off, I'm just going to explain real briefly on how this works. So an idle control valve is basically a controlled vacuum leak. Okay, so you guys who have worked on cars, I'm sure you know that when you have a vacuum leak, the idle is really rough. Normally it idles high, but if it's a MAF-based car, it'll idle low because the car starts to run rich. Now the Miata valve is two parts. The first part is coolant. So mechanically, there's wax in here that when the wax melts, it will actually open and close the valves. Okay, so that's why you have coolant running through them. Now the second one is the as I said, the controlled vacuum leak. And the way this works is that this hose here goes into the actual intake and it bypasses the throttle body. So you've got air coming from the filter here, and then it goes through this hose and it comes out of this port. And the valve basically opens and closes this port for the vacuum leak. So when it's cold, it'll be fully open to cause the vacuum leak, so the idle is really high. And then as it warms up, this valve will begin to close to a certain set point and then stop to still allow air to bypass, but just not as much. So what we're going to do is we're basically going to make a plate that goes here, and it's going to have two fittings coming out of it. So we're going to basically completely block off the coolant side of it altogether. We're not going to use that anymore. We're going to block it off completely because we are on a standalone ECU, so there's not a real reason for that. And essentially, we're just going to have two ports here. And so if you look at the throttle body, like I mentioned earlier, how I said that there's always going to be a small leak, and that's this port here. As you can see, that it's going to bypass into the intake manifold to always allow a small leak. But the large leak side comes from here, and this is the valve that opens and closes. So we're just basically going to make two ports here, and we'll have an external valve. I like to use the Ford ones. We may look at a couple different ones, but essentially that's what we're going to do here. So we'll send this off to John, our 3D print guy, and we'll have him scan this and then see if he can make me a 3D printed plate with both these holes, and then we'll test fit it here to make sure that it's good. Once we test fit it and we know that it fits right, then at that point we'll go back and then add two small portholes and then go from there. Now the downside that we are going to have looking at this all together is that you can see that the hose here is rather large. I think this is, just by looking at it, I think it's a 5/8 hose. Alright, so this is where we're at with the auto air control valve for the Miata. So this is a 5/8 hole here. So we've printed the nipple all together. We're not sure how strong this is going to be. So this is printed out of ABS. It should be good for 220 Fahrenheit. Now the thing is that on the Miatas, there is air constantly running through this. So one of these ports is always open. So we think it's going to be okay. But again, like I said, worst comes to worst, we'll send it off to Cut Sin and get it made out of metal. But we're basically going to give this one a shot. So I think we're good to go here. It's pretty stout. So like basically I can bend it, I can squeeze it, and it feels pretty firm. So I don't think we're gonna have any issues with this guy. All right, so here is our idle control valve here mounted. So we have the plate mounted on the bottom, and this hose, and it's just connected to the hose for now. This hose actually goes back into the intake track. So we just got it together. As you can see, it's not even fully wired in, it's just kind of jammed in there. And I'm going to go test it and see if it works. Okay, so it didn't work out. We tried a couple different settings here and none of it panned out. But just to give you guys an idea on how this works. On the Ford valves, the way it works is that the engine has to produce a lot of vacuum here, and inside there's a plunger. The plunger pulls it completely shut, and when you apply duty to it electrically, it moves open. So I can start the car up, and then you'll see that it'll idle really high. But if I take a screwdriver, I can close the plunger, and then you'll see that with the plunger closed, it'll actually idle really low. Okay, so you can hear it's idling really high. And that's with the valve closed. So watch, if I unplug it electrically, the valve should default closed. And you see the car will come to a complete stall with this shut. And that's how it's supposed to work, obviously. But unfortunately, no matter what we do, there's just not enough engine vacuum. So it's back to the design phase. And this is the part of the job that you guys don't see. You guys just see like the in solutions, but not how we get there. So unfortunately, this is all coming back apart. We're not going to be able to get this all situated. So it all come back apart. We'll redesign this plate here, add a secondary port to it, and hopefully that fixes our problem. So we'll see. So here's the part number for the new idle valve for the Miata. The connector is still the same and the body is still the same. And if you look at it, the plunger is completely different here. And so basically, this is designed for a 4-cylinder vehicle. Obviously, the Miata is a 4-cylinder. And the way it works is that the engine vacuum is going to pull down on this plunger, and that plunger will seal. And once we apply PWM to this, it pulls the plunger up. And the crazy thing that which I thought was really weird, was that I haven't noticed on any of the other valves I've ever worked on have an Allen screw on the bottom. And so obviously that's a little bit, I don't know if it's designed for fine adjustment or what, but as you can see, there's a witness mark or something that they do from the factory there. But I did test this, so I just grabbed the hose and I stuck it into the port just like this, and there was enough engine vacuum to pull this completely shut. And so this did work out where we needed to, what it needs to do. Now the problem is that we're gonna have to go and redesign our plate. So our last plate only had 1 hole opening. We'll have to redesign it where there's 2 hole openings. But the good news is that the gasket is the exact same, so it shouldn't be too hard to redesign this. What I did notice as well, though, on comparing the 2 valves, is that these holes actually look like they're different sizes. So here is here we go. Here's the initial valve that we got here, and you can see that the holes in the body are completely different, which makes sense because obviously this is for a 4-cylinder one and this is one for a V8, so it does require more vacuum to close. And just to show you guys that the mounting holes are basically they're the exact same, so definitely good to go there. Here's our latest and greatest on the IAC here. So if you look, these hoses are actually offset, and the reason is that we originally printed them where they were perfectly symmetrical, but there just was not enough meat to, or it was just way too tight to get hoses on them. We've offset them a little bit, and I really think that this is probably still too tight. But if you look here, even though the hoses are offset, you'll see that with it lined up, it actually has full, the holes are fully inside the offset holes. So there's not going to be any restrictions on the IAC side of it at all. So we're going to go ahead and get some hardware, and we'll tighten this all up and then see if we can get them in. Alright, we have it all attached, and we do actually know that the idle valve is in fact working now. We still have to figure out where to mount it, and we're having issues with the hoses collapsing because there's just so much vacuum on it. So we're trying to make some adjustments here mechanically, and then we'll go from there. So we had to add some of the heater hose 90s down here just to keep everything from kinking, and it seems like it's going to work out just fine. So we're going to go ahead and see if we can get this thing, how this thing's going to idle on its own with the new Ford valve. Alright, so it idles a little high on the initial start, which is how it's actually supposed to act. And then with some luck, it should just kind of come down on its own here. The valve is pretty loud though, I will say. Like, you can actually hear it whirring in there. but it definitely beats not having a valve at all. So I'm going to open up the idle tables here on the ECU and just see where we're at. So I have the valve actually completely closed at the moment. The ECU though is obviously going to command a little bit of it, and that's how it is by design. And it should come down on its own eventually. So we're just gonna let this come down on its own. So how it works is that there's like a baked-in after start, and what that does is that it sets the valve here, and this is cranking. So as the valve's cranking, once it's into its after start mode, that's when it starts to drop down on its own. So we obviously in this table it's commanding 0, so it's slowly working its way down to 0, and that's what we're going to let it do. We're going to let it come all the way down to 0 and then see how the idle's actually set up, and then we'll make our adjustments in these tables. One thing I do want to mention is that this car is on an MS2, and the problem with MS2 is that the idle's not exactly it's not done live, so you have to actually make adjustments and then burn it. So AFRs look pretty good. Obviously you guys are going to see that it idles like the 13s and 14s, and the reason is that he's got really large injectors. They're 1000 cc's and they're still in batch mode, so that's just kind of the way it's going to be. It'll never be perfect. We can go to sequential and they would help out a little bit, but it's not crazy. So this is exactly what we want here. The car's fully warmed up, the idle valve's completely closed, and as you can see, it's basically idling on its own. So what we're going to do now is I'm just going to interpolate this, and then we're going to call it a day. Okay, so idle control is working. Pretty happy. So what was actually happening with the car, it wasn't actually too lean. What actually happened was one of the injectors became unplugged from the plug and play adapter. So we're gonna zip tie those up just to make sure that they stay nice and tight for the customer. But overall, I mean, the car's idling really good. This is not even closed loop idle, surprisingly. This is just regular idle, and it's working pretty damn good. So pretty happy with that. We'll do some cleaning up, but that is our idle control valve kit. So if you guys are interested with the Miata with a standalone ECU and your idle valve has taken a dive and you can't find one for your 1.6, then let us know and we can get you guys all set up on this. Okay, so this is the first start of the day with the new idle control valve. Let's see how it does. All right, cold start. Idle's pretty good, 1200 RPM or so, and then hopefully everything idles down and then it's ready to rock. So now we got the cold start done. We're gonna let it just come up to temp and then just make sure that the idle is good, and it should come right down to 1000 from the 1200 or so that it's at once it's warmed up, and we should be good to go. All right, car is up to temp, idle's right at 1000. That's exactly what we want. So I would say our idle control valve modification is a definite success.